Hello and welcome to the Big Bang Kilonova Hypothesis podcast. My name is Stuart McLean and I am both your host and progenitor of said hypothesis. I was calling my hypothesis the Big Bang Hypernova Hypothesis, and to that end I was planning to use this podcast to go through my essay in which I explain exactly what a hypernova is. But in looking at and considering the large-scale anisotropies, I realized that the pattern of a hypernova was not the best match. Specifically, we see two main anisotropies spiraling out from the central CMB cold spot. Adjacent to the CMB cold spot is what I have come to nickname the CMB hot spot. From two central lobes, one hot and one cold, we see a twin double helical spiral pattern. This double helix shape of the large-scale anisotropies is a mirror to the double spiral pattern formed by gravitational waves seen in simulating the collisions of two neutron stars. The collision of two neutron stars inside our universe is called a kilonova event, which, like a hypernova event, can give birth to a rotating black hole. Seeing as a rotating black hole is critical to my description of the Big Bang, I am able to replace the pattern of a hypernova with that of a kilonova event. In beginning this exploration into the Big Bang Kilonova hypothesis, I find proper context needs to be defined in overcoming what I see as a major psychological block. That psychological block being the very idea that all that exists and could ever be was contained inside the point singularity from which the Landis CDM Models version of the Big Bang began. The contextual background from which the Big Bang Kilonova hypothesis begins comes in defining the Superverse. In order to build that context via general relativity, we begin by looking at that which is born from either a hypernova or kilonova event, namely a rotating black hole. A rotating black hole is critical in my description because the answer I have come to in how our universe was born builds directly upon what general relativity tells us about such objects. Specifically, I make reference to the Penrose diagram showing the interweave between the various spatial and temporal geodesics that we would encounter in falling through a rotating black hole from our universe and out via its associated white hole into a new universe. As an object free falls in towards a black hole, the very metric of spacetime itself is crushed down and compressed because of the extreme concentration of mass energy density that exists within a black hole. This is General Relativity 101 in what Einstein's field equation states. It states how the mass energy density in a given region warps the curvature of spacetime within said region. The greater the mass energy density within a given region, the greater the warping of the curvature of spacetime. Length is defined by light. That is, the very unit of measurement, the meter, is defined by the distance traveled by a photon in a given period of time. Specifically, the meter is the length of the path traveled by light in a vacuum during a time interval of 1 over 299,792,478 of a second. With this definition, we can see how the very metric of spacetime is scaled down and contracted the closer our object is to the black hole. Imagine that our object has a spherical shape for simplicity of description, and attached to our spherical object is a blue light beacon which flashes periodically, emitting a pulse of blue light. We now consider, with respect to a stationary observer that is in geosynchronous orbit around the black hole, what is observed as the object free falls in towards the event horizon of the black hole. Beginning its journey, we see the spherical object free falling in towards the black hole with respect to our stationary position, being a geosynchronous orbit. At the start of the journey, we see regular blue flashes of light being emitted from the beacon, but as the object free falls in towards the black hole, the metric of spacetime is contracted both in time and space, meaning the distance traveled by a photon in a given time interval becomes shorter and shorter as the metric of spacetime is scaled down. The overall volume of space occupied by the spherical object itself becomes smaller and smaller, not because the metric volume of the object itself changes, but rather because the very metric of length itself becomes smaller and smaller. This contraction in the metric of length comes from the increased curvature of spacetime around the black hole. We, the stationary observer, see this compression in spacetime in both the way the blue light emitted from the beacon is increasingly redshifted and in the increased period of time between flashes of light from the infalling object's beacon. Following the path of a photon from the beacon to the observer, the wavelength of the photon continually expands as the metric of spacetime expands. Initially in the blue wavelength, the photon's wavelength expands, turning from blue to green to yellow, orange, red, and on into the infrared part of the electromagnetic spectrum. Thus our observer initially sees blue light being emitted, but as the object free falls in towards the black hole, our observer sees the light being emitted as green, turning to yellow, then orange, and then red, before being redshifted into the invisible infrared part of the spectrum. Time itself is also compressed by the presence of the black hole. The passage of a second in a region close to the event horizon could be equivalent to an entire year with respect to our stationary observer. This implies the length of time between the start of each flash of the beacon, as witnessed by our stationary observer, becomes longer and longer the closer the object is to the event horizon. Ultimately, the light from the beacon, as seen by our stationary observer, will become increasingly redshifted and fainter with less intensity as the wavelength of the photon expands in concert with the expansion of spacetime on its journey towards the observer and away from the black hole's curvature. Coupled to this, the periodicity of the beacon increases again with respect to our stationary observer as the very metric of time is scaled down the closer our object is to the event horizon. The event horizon of a black hole is defined by the speed of light. The escape velocity, the speed required to break free from the gravitational pull of the black hole at any point on the event horizon, is equal to the speed of light. Thus, beyond this point, nothing can ever escape, not even light, because to do so would mean you'd have to have an escape velocity greater than the speed of light. Hence the reason why it is called the event horizon, because no knowledge or information about any event beyond the entrapped bounds of the horizon can ever escape. The very fabric of space-time at the event horizon is scaled down to the point where the metric length is zero. A photon whose direction of travel is away from the black hole will be stationary upon the same point of the event horizon, given that the escape velocity is equal to the speed of light. Both the spatial and temporal dimensions are said to be effectively scaled down to nothing. In effect, the spherical object is crushed down to nothing. Now, in talking about crushing things down with respect to approaching the event horizon, I need to discuss an alternative cosmological model, or rather different models of the same principle, that is currently giving inflation theory the kick-in it deserves. Specifically, I want to talk about an old idea that has been given new form by a number of cosmologists. This idea is the idea of the Big Crunch. Once upon a time, before cosmologists had discovered the shape of the universe and dark energy, there was this idea of the Big Crunch. In effect, the Big Crunch is the Big Bang in reverse. The Big Bang theory itself is the story of how our universe grew and expanded, coming from a giant ball of plasma. The cooling, expansion, and opening up of this giant ball of plasma, such that electrons and protons could bond, forming hydrogen atoms, is what gave rise to the first light that we observe and measure in the form of the cosmic microwave background radiation. This is the Big Bang theory in itself, and this is not in contention. What is in contention is how exactly this came to be the case. The idea of the Big Crunch is the Big Bang in reverse. The expansion of space-time from the moment of the Big Bang has caused galaxies to move away from one another. So the reasoning was posed such that it is natural to ask the question, what if, because of the gravitational attraction of galaxies upon each other, rather than moving away from one another, they actually started to move back towards one another? The conclusion is that galaxies would move towards one another, driven by the attractive force of gravity, such that they would eventually all come together in the Big Crunch. Thus, the end of our universe, according to this story, would in effect be the inverse of the Big Bang itself, a big crunch as the entire universe falls back in upon itself. However, since the discovery of dark energy, and the fact we observe galaxies not just moving away from each other, but rather accelerating, has caused the Big Crunch idea to fall out of favor. But in recent decades, the idea of the Big Crunch model has come back into favor with many eminent cosmologists in a cyclical form. By cyclical, I mean there is a Big Bang expansion of the universe, followed by, for whatever reason, a reversal in expansion leading to a Big Crunch. This Big Crunch in turn leads to another Big Bang event, and so the cycle of birth, death, and rebirth continues. The Janus cosmological model by Jean-Pierre Petit, coupled with Julian Barber's ideas of the Janus point, are a revival of the idea of the Big Crunch. From Jean-Pierre Petit's line of work, this particularly built upon Andrei Sakharov's CPT symmetric cosmological model, which shows two universes, one of matter and the other of antimatter, emerging from the same Big Bang event. But in considering a reverse arrow of time in the parallel universe of antimatter, Jean-Pierre Petit gave reason for why a Big Crunch could arise. Julian Barber's work looks at the origin of the arrow of time in the context of general relativity, from what I understand, I might add. In mentioning CPT symmetry, I would like to draw your attention to my earlier work entitled CPT Symmetry in the Superverse. Another cosmological model that is kind of like the Big Crunch, but is in fact its inverse, is Roger Penrose's Cyclic conformal cosmology model. It is the inverse because in it the universe continues to expand infinitely. It is like the new idea of the Big Crunch because after an eon of expansion, the fabric of the universe conformally maps itself into forming a new Big Bang event and thus is cyclical. It is this cyclical view presented by Roger Penrose that I feel gave courage to the revival of the Big Crunch cyclical cosmological models. I recently came across Professor Paul Jane Steinhardt's Albert Einstein Professor at Princeton University lecture and work on bouncing cosmologies for the Simons Foundation. In his lecture, he presented the work that he and his colleagues have done in understanding the formation and birth of our universe from the perspective of a Big Crunch. Specifically, he compares the expansion of the universe from the moment of the Big Bang, both from the point of view of the Big Crunch and inflation theory. The Big Crunch expansion wipes the floor with inflation, which appears to have a bit of a meltdown, judging from Steinhardt's work. Now, of course, if you're already familiar with my work, you can probably see the decapitation strike coming. From the Big Bang Kilonova or Hypernova Hypothesis prospectus, this Big Crunch is from the scaling down and crushing of the Superverse's metric of spacetime, driven by the curvature of the newly born rotating black hole inside the Superverse. That is, like the journey across the event horizon of a black hole inside our universe, we see the crushing down and compression in the metric of spacetime down to nothing at the event horizon. In turn, so is the fabric of spacetime, which belongs to the Superverse, is crushed down as it comes close to the event horizon of the Superverse's rotating black hole. Cool, glad we've got that one out of the way. On with the show. In crossing over the event horizon of the black hole, we consider the effect from the point of view of our object free falling down towards singularity at the heart of a black hole. This point of view is best expressed in considering the Penrose diagram of a non-rotating black hole, also known as a Schwarzschild black hole. Here, in this diagram, there are two conformally separate regions of spacetime. One region shows our universe, and the other region shows the entrapped curvature inside the black hole itself. Now, as the object is in free fall in towards the black hole, it thus implies that it is travelling at the speed of light. Beyond the event horizon, our object has been accelerated to speeds faster than the speed of light. In considering the effects of travelling faster than the speed of light, physicists, considering special relativity, realized that the very role a dimension has is swapped. That is, the dimension of time becomes a unidirectional spatial dimension, and the three spatial dimensions that we know become three temporal dimensions. In effect, at the event horizon, the spatial and temporal fabric of spacetime is crushed down to zero and then inverted. Time becomes space, and space becomes time. We describe our universe of three spatial dimensions and one temporal dimension as being a spatial geodesic. Across the event horizon, in a non-rotating black hole, there is only one spatial path available, and that is down towards the gravitational singularity at its center. Here, inside the black hole, reality consists of one unidirectional spatial dimension and three temporal dimensions in what is called a time geodesic. This transition of a spatial dimension into a temporal dimension is reflected in the Penrose diagram by the color of the grid lines within a given geodesic. A red line represents a spatial or space-like dimension. A blue line represents a temporal or time-like dimension. So inside our universe, the red spatial dimensions runs in a horizontal direction and the blue temporal dimension runs in a vertical direction. Vice versa, once inside the time geodesic of the black hole, the dimensions swap such that the blue temporal dimension runs horizontally and the red spatial dimension runs vertically down towards the point singularity at its center. As a note, I am using the word geodesic, which effectively describes the curved path one object follows, which from my understanding is the closest or best mathematical term that gives voice to the idea of dimensional rule swapping. Here I am effectively using it to describe the composition of a given region upon the Penrose diagram. Another feature of a Penrose diagram is that it can be extended in considering the time-reversed solution. So at the moment, The shown Penrose diagram only shows the time-forward solution, but to make it complete, we consider the symmetric case where the arrow of time is reversed. This time-reversed solution is shown here on this Penrose diagram, which shows the complete or extended solution for a non-rotating black hole. On the left-hand side, we have a parallel universe to our own, whose arrow of time is inverted to our own. This new parallel universe, with its own arrow of time, which is inverted to our universe's arrow of time, is also spoken for in quantum mechanics, specifically in considering the work of Andrei Sakharov and the consequences of CPT symmetry. Also, it is seen in the aforementioned cyclic Big Crunch cosmological models. More critically, in describing the path two opposing particles take in the formation of astrophysical jets, I previously presented a very simplistic mathematical argument as to why we find ourselves living in a CPT symmetric universe. We live in a CPT symmetric universe for a reason. That reason being because our universe is in fact a jetiverse. For that work, please see my CPT symmetry inside the Superverse film. But returning to our maximally extended Penrose diagram showing the solution of a non-rotating black hole, we also see in the bottom the mirror image of a black hole, namely a white hole. This is where the idea of a white hole came from in considering the time-reverse solution to a black hole. The reason we have never observed a white hole is because, as we'll see, is that for every pair of jetiverses, there is only ever one white hole, the true lambda. The one that gave birth to our universe is located in what is now the Eridanus supervoid, beyond the observable cosmic horizon. A white hole is a time-reversed black hole. Rather than consuming, scaling, compressing, and crushing the fabric of space-time, it is the inverse, being like a fountain of expanding space-time. Everything inside the black hole is destined to fall onto and become part of the gravitational singularity at its center. In inverse, everything inside a white hole comes forth from its gravitational singularity, with only one path of travel up and away from the singularity. Through the time geodesic of the white hole, a particle can either find itself inside our universe or inside our time-reversed twin parallel universe. Another important point is that nothing can cross the event horizon from our universe into the white hole, not even light. A photon upon the event horizon whose direction of travel is down toward the white hole's singularity would be stationary, sort of like light in a Bose-Einstein condensate, which is almost stationary. For these reasons, white holes have been used as a solution in explaining what exactly caused the Big Bang. Rather than consuming the universe, like a black hole, they do the inverse and give birth to a pair of twin parallel universes, each with a reverse arrow of time with respect to the other. In the Big Bang Kilonova Hypothesis, I specifically employed the description given for a rotating white hole in describing how and why our universe was born. The reason for this is because of what a maximally extended Penrose diagram of a rotating Kerr black hole shows. Starting from the bottom of this diagram, we see two parallel universes. Each is time reversed with respect to the other. We enter the rotating black hole either from our universe across the event horizon or from the parallel universe via the parallel event horizon. Because of the rotational nature expressed in the Kerr metric, we find a solution whereby the point singularity is no longer a point. Rather, the singularity is spun into a ringularity. This spinning ringularity opens up into becoming a very special kind of spatial geodesic called a wormhole. It is a place where effect can precede cause. For instance, a ball hits you on the back of the head. You pick it up and throw it. Being inside a wormhole, the reason a ball hits your head is because you subsequently pick it up and throw it. Though this is certainly no kind of wormhole that is a gateway or passage we could use for interstellar travel. Rather, I would say the wormhole is entrapped. It is entrapped inside the spatial volume within our own universe, occupied by the associated rotating black hole, meaning that which enters the mouth of the wormhole via falling into the black hole before exiting it via the associated white hole happens inside the spatial volume of our universe in which the rotating black hole resides. Black holes now can effectively be described as being entrapped surfaces of spacetime with positive mass. In fact, it is this very description that Roger Penrose employed in effectively showing that black holes are a real consequence of general relativity, and for which he was given the 2020 Nobel Prize in Physics, specifically for this description of entrapped spacetime with positive mass. The unique part I now extrapolate from is in realizing that given the fabric of spacetime is itself entrapped, then so too is the wormhole. Specifically, the wormhole inside the volume of the rotating black hole is entrapped in there. This is opposed to the traditional view of a wormhole, which imagines a bridge in spacetime that can span vast interstellar distances. Rather, the entrance and exit of the wormhole are entrapped inside the volume of the rotating black hole. Falling through the entrapped wormhole, we cross over the inner anti-horizon, passing into the time-reversed black hole, which is a rotating white hole. Just like the non-rotating white hole, everything that falls into this time geodesic will be ejected out into one of two universes. But rather than exiting into the spatial geodesics of our universe and our associated parallel universe, it exits into a pair of parallel new universes. However, because the wormhole is entrapped, this pair of new universes grows and expands in the spatial region surrounding the rotating black hole. In considering the birth of a rotating black hole, we see it giving birth to a rotating white hole, which in turn ejects the entrapped surface of spacetime. This ejection via the newly born rotating white hole I equate to blowing a balloon full of air. As the balloon is inflated with air, so too does that air become entrapped within and by the surface of the balloon. The only path by which air can escape from the balloon is back out through the nozzle. However, the entrapped balloon of spacetime's nozzle is a white hole into which nothing can enter. So in effect, a pair of new universes are born in the spatial region surrounding the volume of the newly born black hole. The nozzle end of the pair of balloon universes is located at each of the polar regions of the rotating black hole. Effectively, a given universe can be considered as being like a closed balloon of entrapped spacetime which is being inflated from the associated white hole, that is in turn causally connected to the black hole. The spatial volume into which the pair of balloon universes are being inflated is mostly flat because the surrounding parent universe has a mostly flat curvature. With this description in mind, let us consider the ramifications for a black hole inside our own universe. It would mean that two entrapped balloons or bubbles of causally closed spacetime will inflate from the polar regions surrounding the black hole. Any mass that has fallen into the black hole will be injected into the pair of parallel balloon universes. That mass would first be causally entrapped within either of the two balloon universes into which it fell, but in turn the entire volume and mass of this pair of new universes would be completely enveloped inside our own universe. Effectively, these new pair of balloon universes I will refer to as being subverses, because in totality it is a subset of our actual universe. And where exactly are these balloon subverses to be found? Inflating forth from the polar regions of the given black hole. In this single description, I have effectively explained why dark matter is dark matter and why it has no particle representation. In effect, dark matter is matter inside the volume of our own universe, which is causally disconnected. Or rather, the connection to dark matter is to follow it in through the rotating black hole. After half a century of searching for a dark matter particle, we have nothing. So this is my explanation for dark matter, in that it is the volume of matter which is consumed by the rotating black hole and injected into the balloon subverses within our own universe. For the numerous arguments and reasons that I present in my various essays, in particular my general relativity and rotation essay, I argue that there is a physical interaction between the entrapped bubble of spacetime that is a subverse and the surrounding parent universe. Specifically, the fields that make up the physical reality of a subverse are derived from the fields of the parent universe that gave birth to it. In effect, I reason that there is a causal relationship between the gravitational field of a given subverse and the electromagnetic field of its parent universe. So, an extremely high energy event upon the gravitational fabric of a given subverse, such as a kilonova or hypernova event, would translate into a high energy event upon the electromagnetic field of the surrounding parent universe. Thus, such an event would be seen in the parent universe by the production of high-energy gamma-ray photons. Discovered by the Fermi X-ray telescope in 2010, Fermi bubbles are two large balloon-like structures whose total span is 50,000 light-years in length. Extending from the Milky Way's galactic center, these two gigantic bubble-like structures dominate the intergalactic void around the northern and southern polar regions of our very own spiral galaxy. Emitting X-rays and gamma rays, these Fermi bubbles are only visible in the very high energy band of the electromagnetic spectrum, obscured by other X-ray and gamma ray sources within our own galaxy. The identification of this previously unknown massive structure to our very own Milky Way was a complete surprise to astronomers. The origin of Fermi bubbles is believed by many scientists to be centered upon the Sagittarius A star supermassive black hole that resides at the very center of our own Milky Way galaxy. When such a supermassive black hole feeds, it produces a pair of astrophysical jets that shoot out into the intergalactic polar regions adjacent to the galaxy. In the case of our own Milky Way galaxy, the direction of travel of the astrophysical jets would be directly through the center of the volume occupied by the newly identified Fermi bubbles. As an example, we have this paper entitled Simulating the Fermi Bubbles as Forward Shocks Driven by Active Galactic Nuclei Jets, discussing the possibility that only 5 million years ago our very own Milky Way galaxy was for a time a quasar. In fact, the European space agencies XMM Newton X-ray telescope has found a direct causal connection between the larger Fermi bubbles and Sagittarius A star in the structural formation of the identified northern chimney leading to the northern Fermi bubble. Vice versa, a southern chimney is also identified leading to the southern Fermi bubble. Given our description of considering a pair of subverses being born from a rotational black hole, we have a much simpler explanation to the observation of Fermi bubbles, which in turn seeks to answer two very critical questions, namely, what exactly is dark matter, and what happens to the information that falls inside a black hole. The idea of dark matter was first given form in trying to explain the observed rotational velocity of stars within a given spiral galaxy. Stars at the edge of a given galaxy had a far higher rate of rotation than expected, given the law of gravity. The idea of dark matter was born in the postulation of there being an invisible form of matter that must surround the entire galaxy. It is this hidden or dark mass of matter that is responsible for the observed rotational velocity of stars. So, in putting forth an explanation for dark matter, the location, shape, and volume occupied by the given Fermi bubbles is key. Although the full halo of dark matter that surrounds the Milky Way has come from many different feeding events, the Fermi bubbles, I believe, come from the last time Sagittarius A star fed. At some point in the distant past, the Sagittarius A star supermassive black hole had a massive feeding frenzy, and for a time, our Milky Way galaxy became a quasar. Falling through the rotational black hole, the swallowed matter and fields of our universe fall through the entrapped wormhole before being ejected out into either one of the two subverses via the associated supermassive rotational white hole. This matter is now causally enclosed inside either of the two growing bubbles of entrapped spacetime. Following both the logic of fractal geometry, coupled with the realization that the fields of these subverses are derived from our own universe, I imagine that a smaller scaled version of our universe evolves within this pair of bubble subverses. Following this pattern means that high-energy events such as hypernovae or kilonovae events in turn happen in the subverse. I will also note that due to the much smaller scale, the rate of time inside a given subverse is much faster with respect to its parent universe, meaning a week for us here on Earth could be the equivalent to a span of around 4 billion years inside a subverse. Genesis, after all, is a matter of perspective. The main point being that the rate of such high-energy events inside the subverse is of a sufficiently high enough rate that the very fabric volume of the subverse, being derived from the electromagnetic field, effectively glows in the X-ray and gamma-ray part of the spectrum inside our own universe. In totality, this glow comes from the matter that has previously fallen into the Sagittarius A star black hole. The information entangled within the gamma-ray photons of the Fermi bubbles has come from information that had previously fallen through the event horizon of the Sagittarius A star supermassive black hole. Thus, I am able to get an attack vector into resolving the infamous black hole information paradox. Another observation that has got me very excited is a composite image of the Milky Way's galactic core as seen in both X-ray and radio. It got me excited because of the large number of both chromosomal-like threads and the helical spiral shapes, Making reference to my CPT symmetry inside the Superverse episode, I rendered helical spiral pattern artwork in depicting the spiral shape of an astrophysical jet. Now here in this picture, we can clearly see two helical spirals originating from the same point in space. Coupled to this is the chromosonal shapes of other subverses, closing into a single central point at the center, the DNA of our Milky Way galaxy. One extremely interesting thread that glows both in the X-ray and radio wavelength is G017-0.41, as detailed in this paper. Applying the same logic with respect to rotational black holes born from hypernovae and kilonova events, we imagine the birth of a pair of subverses arising from such events. The birth of a rotational black hole in turn leads to the birth of a rotational white hole from which a pair of balloon subverses inflate. These subverses, being derived from the electromagnetic field, interact with it, in turn emits photons making it glow. Now, being much smaller subverses with respect to the Fermi bubbles, high energy events inside these subverses may translate into the production of low energy photons inside our universe. Thus, the glow of such subverses we would see in the radio band of the electromagnetic spectrum. Looking at the radio image of the composite, we could imagine that we are seeing the glow of the CPT symmetric jetiverses populating the nucleus of our very own galaxy. Though it must be stressed, there can be many other explanations as to what is responsible for all these threads and helical spiral patterns. Astrophysical jet formation that happens as a star is born is one such radio source. So as tempting as it may be to imagine subverses everywhere, other things are also shaped by the electromagnetic force and its associated weather patterns. However, in the case of Fermi bubbles, I think the case for a pair of subverses is far more clean-cut, as it both explains dark matter in tandem with physical observation of a single identifiable structure in the depths of the intergalactic void. Finally, with this description now given, I come finally to being able to define the superverse properly. In totality, this pattern of a rotating black hole giving birth to a pair of subverses inside our own universe is one of scaled recursion. This is the key to understanding the Big Bang Kilonova Hypothesis, this idea of scaled recursion via a black hole. A rotating black hole inside our own universe scales and compresses the fabric of space-time, effectively turning it inside out before then ejecting it into a pair of bubble subverses. These subverses are scaled-down versions of our own universe, given that the fields are born from the quantum and gravitational fields derived from our universe. Effectively, we can say the fields of the subverse are derived or inherited from the parent fields inside our own causally connected universe. So by looking at this image from the Chandra X-ray Observatory of the Milky Way's galactic core, we can imagine being an observer inside the superverse, witnessing the ghostly imprint of our own helical spiral universe. The superverse is effectively the same as our own universe, but at a much larger scale. In the beginning, for the first couple of years, I had a vision of the Big Bang being like two astrophysical jets. The appeal of thinking about the Big Bang as having the shape and structure of two massive astrophysical jets came in seeing it as a solution to the matter and antimatter asymmetry problem. But in trying to explain where do these jets come from, there was a hole in my mind. Originally, I was thinking more in terms of some kind of active galaxy with one of the resultant jets being our universe. Another was in thinking about a massive star-like object that goes nova. But in trying to actually visualize this, I realized I had a massive roadblock in my thought process. That thought block being the basic assumption that all that we can see, measure, and know about was contained inside the Big Bang. This basic assumption paints a picture of there being no clock, no second, no hour of time before the moment of the Big Bang. Effectively, it holds that space and time only came into existence at the very moment of the Big Bang. The concept that objects could exist outside of our universe is alien. The concept that our universe is expanding and occupying the three-dimensional spatial volume of a causally independent reality is alien. I honestly find it hard to put into words the mental brain blockage I had arising from this very basic and very reasonable assumption. It is for this reason why I have gone through the whole concept of entrapped surfaces of spacetime and the recursive nature before even touching the definition of the superverse in this here podcast. It is only in laying out my latest fully reasoned version based primarily around general relativity that I feel I am able to hopefully give yourself permission to question this basic assumption, which, as I will attempt to show, is clearly false. So in thinking about an active galaxy or a massive star feeding the Big Bang, I was more swaying into an active galaxy. The primary reason was one of scale, and a supermassive black hole had far more appeal than a small, newly born black hole. The idea of such a massive star was extremely far-fetched. That vision of things changed in about 5 seconds for me. What changed me in such rapid succession was the presence of the spherical Bianchi supervoid, measuring 330 million light-years in diameter. In an instant, I had found my massive star-like object, and in that moment, the Big Bang Hypernova hypothesis was truly born and given form. In a single instance, I had my massive star-like object. The Bianchi supervoid is described as being a void full of dark energy. Dark energy is described as being like dark matter in that we cannot see it or observe anything about it, but we know it must exist because we can see its effects. But unlike dark matter, which has an attractive gravitational pull, dark energy has a repulsive anti-gravity type of effect. Now, given the assumption that everything was inside the Big Bang, then that includes dark energy as a component of the equation in the makeup of our universe. The absolute farcical nature of this assumption is best summed up in looking at this graph from Wikipedia's dark energy page, which shows the estimated division of total energy in the universe into matter, and dark energy based on 5 years of WMAP data. On top, we see that the universe as it is today is composed of 72% dark energy. On bottom is the estimation of the composition based on 5 years of WMAP data of the universe at the time of the cosmic microwave background radiation was composed of no dark energy. And this is what I would expect given the Big Bang Kilonova Hypothesis assumption that an object composed of dark energy is an object outside of our universe belonging to the reality I call the Superverse. That is, there should be no or very little dark energy in the very early universe. Trouble is, the vast majority of mainstream cosmologists never managed to get around this mental brain blockage and instead invented the mathematical hack of inflation theory. For my hypothesis, the problem of dark energy is very simple in that it represents a mass energy density that does not belong and is causally disconnected from anything inside our own entrapped surface of spacetime with positive mass. Remembering, in describing our universe, I have built upon Roger Penrose's idea of entrapped spacetime with positive mass. So in describing dark energy with a negative mass anti-gravitational effect, I describe it as being outside this entrapped bubble of spacetime. So in the case of the Bianchi supervoid, we have a spherical concentration of mass energy density. In trying to imagine a massive star-like object whose mass and size is sufficiently large enough that it can account for all the matter inside our observable universe, I had found my match. That is, given the pattern of a hypernova, whereupon when this star comes to the end of its life, then by a rough guesstimate, such an object would have enough matter that it could account for that which we see in our observable universe. Now, I should point out that actual hypernova events only happen with very specific types of massive blue supergiants inside our own universe, but the presence of at least one star in the expanse I have come to call the Superverse, whose size is so overwhelmingly titanic in proportion relative to our own universe, was enough for me. Remember that if I stack copies of our own Milky Way galaxy end to end, in traversing the diameter of the Bianchi supervoid, I would need 3,300 galaxies. The Milky Way galaxy being 100,000 light years in diameter, whereas the Bianchi supervoid is 330 million light years in diameter. The Bianchi supervoid occupies around 0.27% of the volume of the observable universe. Now, I will say that if the Bianchi supervoid had not existed, I would never have been able to imagine such a massive star-like object that I came to call a McLean in a massive fit of egotistical vandalism. But as a note, I am still very tempted to simply call it a Boaty McBoatface, for the simple reason it puts a smile on my face. In developing a means of testing my ideas that the Bianchi supervoid is in fact a massive star-like object, or really simply a star belonging to the Superverse, then I consider the formation of the Bianchi supervoid. Being an object external to our universe, and being an object whose spherical volume lies in the path of our expanding universe, then it would mean that our universe should be seen to be flowing around it. Like a stone in a river, the water of the river flows around the stone, is the analogy that I can best think of. Our universe, like the river, encounters a solid object, the Bianchi's McLean, a star of the Superverse, and thus flows around it. Thus, I am able to test my idea in wanting to see if galaxies are actually flowing around it, coming from a general direction. That general direction from which the universe is expanding and flowing from has its source in the Eridanus supervoid. Now, in comparison to this is the story told by the Landis CDM model, in which voids and supervoids behave in a manner similar to soap bubbles, starting with the assumption that the cosmological principle is both homogeneous and isotropic. Simulations begin by showing such a mixture of galaxies. The idea is that arising from the effects of the purely hypothetical inflation field, small bubbles of dark energy begin to form. These bubbles of dark energy coalesce over time, growing larger, forming voids and then supervoids. Galaxies composed of ordinary and dark matter are attracted to each other and thus over time coalesce to form clusters and superclusters. In the same manner, bubbles of dark energy coalesce into forming larger and larger voids as they are attracted to one another while simultaneously being repelled away from galaxies composed of matter. Given this, I would expect there to be no general direction of flow around the Bianchi supervoid. Unfortunately, I have not come across a study which maps out the observed velocity and movement of galaxies around the Bianchi supervoid specifically. However, R. Brent Tully's paper entitled Cosmic Flows 3 Cosmography of the Local Void does provide such a map, specifically Figure 3. Here we can see the flow of galaxies around the local void more or less all flowing in the same general direction. This flow in this direction is attributed to our local supercluster's attractive movement towards a hypothetical mass called the Great Attractor. Rather, I see it as a very successful demonstration in being able to show the validity of my ideas about dark energy and the superverse. However, I will note that the orbits shown are derived from numerical action methods, and I am not sure how a realistic picture it paints. But then again, the flow in the direction of the Great Attractor was not an unexpected result. Even so, this is to me vindication of my ideas about dark energy versus the Lambda CDM models explanation. And of course, I am sure there is no problem or any controversy in arguing that the universe at 13.8 billion years old is not sufficiently old enough for a void structure such as the Bianchi supervoid to have formed. Forgive my sarcasm in opening up an old wound. The classification and answer, what exactly dark matter and dark energy truly are, in the context of the Big Bang Kilonova Hypothesis, is thus beautifully simple. Dark matter is that matter contained inside any subverse that exists inside our own universe. This dark matter has been causally disconnected from our universe because it has subsequently fallen into a rotating black hole, before being subsequently ejected out into the associated pair of subverses. Dark energy is any mass energy density that exists outside the causal confines of our own universe and belongs specifically to our surrounding parent superverse. So what exactly is the superverse? Well, coming back to this picture of the Milky Way's galactic core, we see the helical CPT symmetric spirals of subverses born inside our own galaxy. A star in our own galaxy would appear to that subverse as the Bianchi supervoid appears to us. We can see the subverses here expanding into the mostly flat spatial volume inside our own universe. The philosophical basis from which I build my argument is to say that fractal geometry is the cosmological principle. One implication of this is that self-similar patterns repeat themselves irrespective of scale. So, whether the diameter of a star is a meter inside a subverse, or a star is around 1,000,000 kilometers in our own universe, or if a star has a diameter of 330 million light years in the superverse, the pattern of a star is a star. Now, in mentioning scale, the very basis of my idea from the get-go was seeing the same pattern of gamma-ray jet formation at multiple scales. At the scale of electron-positron annihilation, at the scale of a hypernova, or at the scale of the Big Bang in using a hypernova to explain it. This is what I am meaning in saying that fractal geometry is the cosmological principle and that self-similar patterns repeat themselves irrespective of scale. Another very important ingredient in fractal geometry is that of recursion. As we have already seen, a black hole is effectively a transform operation of scaled recursion that takes the fields of a parent verse and transforms it in, reducing its scale, giving birth to a pair of child verses. The fields of the child verse are derived from the fields of the parent verse. Thus, a much smaller scaled version of one verse can be born inside another. There is no fine-tuning of constants, or some all-powerful singular God determining what those constants were at the very moment of the Big Bang. So, as for the question of God and the moment of creation, well, I don't need to lean on any supernatural explanations. Okay, yes, there is the inspirational artwork and the story of me building my entire hypothesis around it, and a tale to be told in who drew that artwork. After 2,000 years, what does humanity end up with? Me. Oh, bugger. Anyway, to answer the question, what exactly is the Superverse? It is simply the parent universe to our own, which looks and behaves in the same manner as our very own universe. As a subverse is a child universe to us, so too is our universe a subverse of the larger superverse. Effectively, the volume into which our universe is expanding is mostly flat, existing space within the superverse, or the volume occupied by our own universe is but a subset of the volume of the much larger superset volume of the superverse, hence the name. Finally, with all that said, I can come back to what I originally wanted to describe in this particular podcast, namely to describe my Big Bang Kilonova Hypothesis, but in the course of doing so, I realized I really needed to give context to the superverse, particularly in the light of general relativity. Without this context of the superverse, my explanation for the Big Bang Kilonova Hypothesis would make no sense, primarily because of this mental blockage of assuming time began only when the Big Bang event happened. The great thing about my context of the superverse is at least I can provide proof of my primordial atom, namely the McLean, in the Bianchi supervoid. This star I was using as a basis in describing the pattern of hypernova. In fact, as mentioned in my previous podcast, I wanted very specifically to go through my carefully prepared essay in answering what is a hypernova. The short answer to that question is that it is a very particular type of core collapse supernova, whereby a massive dense blue supergiant with a high rotation speed burns through all its fuel. Triggered by the fusion of iron and driven by what is called the R process of nucleosynthesis, the fusion of heavier elements through the electron capture process, the core collapse sees in upon itself, driven by the force of gravity. What is special about a hypernova is that a rotational black hole is born from the collapsing core. Rotation is the critical factor. Specifically, as the core collapses, its angular momentum becomes faster and faster. This has the effect of giving birth to a rotating black hole at the core, while simultaneously increasing the angular momentum of the surrounding plasma. Driven by the accelerated rotation of plasma, a solenoid-shaped magnetic field is thus generated within the dying star. This solenoid magnetic field effectively shapes and channels the nova's explosive energy along the axis of rotation, leading to the formation of two astrophysical jets. The light energy of these jets are extremely high energy gamma rays, which in totality we observe as a long gamma ray burst. The pattern of a hypernova is to give birth to a rotating black hole, coupled with the nucleosynthesis of heavier elements by the aforementioned R process. And certainly the study of hypernovae is an extremely exciting area of astrophysics. Before the ink is even dry on the page, yet another discovery or observation regarding hypernovae is announced. A paper this very week past describes the detection of heavy elements inside a very ancient star, which was born around 300 million years after the Big Bang itself. Such an ancient star should only be composed of lighter elements, all of which are derived from the fusion of the first hydrogen atoms, from which the star was born. All elements heavier than hydrogen have come from the fusion of atoms at the core. However, the nucleosynthesis fusion process of all elements heavier than iron only happens at the very end of a star's life. Because of this implication, it means that one would expect such an ancient star, originally composed of only hydrogen, to not be composed of any heavy elements. But in the case of the ancient star in question, this is not the case. Seeing as the ancient star does in fact have heavier elements, then it must have been in close proximity to an event in which this R process nucleosynthesis occurred. Given the specifics of the star's composition, this particular event is believed to be due to an actual hypernova event. Another very exciting piece of work comes directly from NASA's work in relation to the observed gamma-ray burst GRB 2008-26A. Looking at jet formation simulations, such as those produced by Phil Mosta et al. At Caltech, we can see how the jet forms inside the collapsing core. From there, the astrophysical jet pushes through the collapsing mass of the star, such that it escapes to traverse the vacuum of space, such that we observe it as a long gamma-ray burst. What was unusual about GRB 2008-26A was that a short gamma-ray burst was observed, and this is most commonly associated with a kilonova event, the main subject of this here podcast. So when astronomers found it had come from a hypernova, seeing the fading light of the dying star, it turned out to be unexpected. But from the aforementioned simulations, some have shown the beginning of jet formation inside the star, but as it travels towards the surface, it loses energy. In fact, it may lose so much energy that the jet more or less fizzles out, so rather than a long gamma-ray burst, we observe a much shorter gamma-ray burst. With the headlines read in regard to hypernova news done, I can get on with the main subject of this podcast, specifically the reasons for changing my hypothesis to the Big Bang Kilonova Hypothesis. So firstly, what is a kilonova? When two massively compact bodies such as neutron stars or black holes collide, the resultant high-energy explosion we call a kilonova event. So in order to understand a kilonova, we need to understand the physical object we have come to call a neutron star. Fortunately for me is the fact that I have just described the event process by which a neutron star is born. Specifically, a neutron star is also born from a hypernova event. Now, in the context of my hypothesis, I specifically make reference to hypernovae and kilonovae events in describing how a rotational black hole is born. However, in more general terms, a hypernovae can give birth to either a neutron star or a black hole. Also, with respect to a kilonova, it could be the merger of a neutron star with an existing black hole, or two black holes themselves merging. But when, in specific reference to my hypothesis, I am looking to describe the birth of a known gravitational singularity, a rotational black hole, in equating it with the birth of our universe, and the Big Bang's unknown type of gravitational singularity. A neutron star is born in the same manner as a black hole, arising from the core collapse of a massive star. The weight of a massive star pushes down upon itself such that the atoms at the core are crushed together, causing them to fuse with one another. The energy released from this fusion process holds the star in shape as it pushes back against the gravitational collapse of the star upon itself. As the star ages, it fuses the lighter elements into heavier elements. Hydrogen turns to helium, which in turn will later be fused into beryllium and carbon. hydrogen requires less pressure to fuse than helium, and so for this reason a star will burn through its entire hydrogen fuel source before helium fusion begins. As hydrogen is depleted, there is a decrease in the outward fusion force, which in turn causes the star to collapse down on itself, driven by the inward force of gravity. This in turn causes the temperatures and pressures at the core to rise to the critical levels required for the fusion of helium to begin. The ignition of helium fusion returns the outward force as a new balance of equilibrium between gravity and fusion is reached. In the case of our own Sun, some 4 billion years from now, it will swell up into becoming a red giant. In the case of a Type 2 supernova, a supernova driven by core collapse, the star has sufficient mass, density and size such that this fusion cycle of heavier and heavier elements can occur. With each change in the fuel source, the star collapses further down upon itself, leading to the fusion of heavier elements. This cross-sectional image of a supergiant demonstrates the sequence of nucleosynthesis that forms all the elements lighter than iron. The fusion of all elements heavier than iron is driven by the rapid capture of neutrons. It is the letter R in the word rapid, as in rapid neutron capture, that gives this form of nucleosynthesis process its name, the R process. The R process itself requires an environment high in free neutrons, such that the rapid neutron capture fusion process can happen. Here, the nucleus of an atom fuses with a free neutron, a reaction that absorbs energy as opposed to releasing it. It is this absorption of energy by the fusion of all elements heavier than iron that is the triggering mechanism for a Type 2 core collapse supernova to occur. Suddenly, the outward force driven by the release of fusion energy is gone and gravity finally wins. The pressure at the very core generates a form of matter known as an electron degenerate form of matter. Effectively, all the free space inside each atom is crushed out, leaving atomic nuclei in a sea of electrons, a conglomerate of atomic nuclei, a stellar example of the Pauli exclusion principle where no 2 electrons can occupy the same identical state. Now, beta minus decay is the radioactive decay of an atomic nucleus by which a neutron decays, releasing both a proton and an electron. However, because of the high electron density arising from the electron degenerate form of matter, the process of radioactive beta minus decay is blocked. Rather, a free neutron is released, and it is all these freed neutrons that are in turn captured and fused with other atomic nucleus. This is the R process nucleosynthesis in action. For stars whose original stellar mass is between 10 to 25 stellar masses, the resultant remnant of the core after the star has gone nova is called a white dwarf. A white dwarf is effectively this electron degenerate form of matter, an atomic conglomerate that was the core of the now dead star. 1 teaspoon of a white dwarf would weigh around 5 tons, such is the mass of this atomic conglomerate. A white dwarf itself has a maximal weight of 1.44 solar masses, known as the Chandrasekhar limit. As the core collapses and contracts, all the lowest electron energy levels are filled and the electrons are forced into higher and higher energy levels, filling the unoccupied energy levels. This creates an effective pressure which prevents further gravitational collapse. However, there is a limit to the number of energy levels that can be occupied and thus a maximum weight limit that an electron degenerate body can have. This maximal weight limit was calculated by Subramanian Chandrasekhar on his voyage from India to England to study physics at Cambridge. If the mass of the electron-degenerate material at the heart of the collapsing core exceeds this limit, then it forces the electrons to fuse with the protons of the atomic nuclei within this conglomerate mixture. The fusion of an electron with a proton in turn creates a neutron. Thus the electrons and protons in the degenerate matter are fused together, leaving only neutrons. Now again, arising from Pauli exclusion principle, no two neutrons can occupy the same identical state. Thus, a neutron star is born, composed of only neutrons. In effect, I would say the volume of space occupied by the weak universe is forced out, the weak universe being the vacuum space bounded between the quark concentric ring and the electron concentric ring. Force inside the weak universe is conducted by the Z and W bosons. In effect, the electromagnetic and weak nuclear force are unified into becoming the electroweak force as the core collapses down from being a white dwarf into a neutron star. A neutron star, in totality, is a mass of neutrons packed so tightly together that no free space remains. 1 teaspoon of a neutron star would weigh around 1 billion tons. Effectively, it is a perfectly homogeneous mass composed of neutrons. As this is such an important point, I'll repeat that. Effectively, it is a perfectly homogeneous mass composed of neutrons. It is very important in considering the sacred cosmological principle of the Landau-CDM model. Specifically, it says that the mass-energy density of the universe is both homogeneous and isotropic at a sufficiently large enough scale. The primary reason for stating this is because we see an observable universe filled with trillions of spiral or elliptical galaxies that in turn contain hundreds of billions of stars. From the spectral signatures of these galaxies, we see that they are composed of the same atomic elements as we are composed of here on Earth. In other words, the laws of physics are universal, the same, throughout the observable universe. That which is here on Earth, as it is in heaven, is by the laws of physics given form in the will of the system, and to know the wave equation of an entire system in a given moment is to have perfect knowledge of both the past and present of that system. For our story, that is Sol. But all systems operate by the same universal laws of physics, and those laws lead us to giving description into how and why a perfectly homogeneous mass that is a neutron star can be born. In saying fractal cosmology is a cosmological principle in terms both of scale invariance and recursion is what has allowed me to develop the Big Bang Hypernova hypothesis. Effectively, I'll try to imagine a star-like object measuring 330 million light-years across, existing in a spherical buoyancy supervoid. By imagining the life and death of such a star, I could imagine its core collapsing so completely that a new rotating black hole is born in a place I have come to call the Superverse. A key argument of mine is that our universe is the way we find it because the fields that make up our universe are inherited from our parent Superverse, or rather, scaled down and turned inside out by the black hole born in the Big Bang Hypernova event. How exactly each of the concentric fields and their subsequent vacuum spaces are scaled down and turned inside out is a question that can be viewed through the lens of seeing how the weak universe is forced out as a white dwarf collapses into a neutron star. This view can be extended in describing how a neutron star collapses down into a black hole. That is, if the mass of the neutron star exceeds 2 to 3 solar masses, then it will undergo gravitational collapse, or rather, the vacuum space occupied by the gluon universe between the central Higgs field and the concentric quark field is squeezed out, giving birth to a particle born the gravitational field, a black hole. The electroweak and strong nuclear forces are unified as the neutrons themselves fuse together into a single cohesive mass. It is an interesting line of thought, and one I need to think about further, particularly in combination with seeing how frame dragging affects the conformal nature of spacetime. But for the moment, it gives us insight into how an entrapped surface of spacetime can be turned inside out, such that it creates a new pair of bubble S-1 subverses. That is in the case of a black hole being born inside our own universe. For the Big Bang itself, it was a black hole being born inside the Superverse that gave rise to our own Jetaverse, plus our twin Jetaverse of antimatter. But how was that black hole in the Superverse actually born? Well, given the Big Bang Hypernova hypothesis, I give explanation by way of a hypernova of a McLean, a fantastic sight to see, particularly after downing 20 cans of cider, snorting several mountainous lines of coke before sticking a flare up your own arse, lighting it, and running into the crash the grand party. It always seems like a good idea at the time, but you end up having some reservations while your backside undergoes reconstructive surgery. It certainly does give a new definition and meaning to the phrase pain in the arse. That man is a legend in my opinion. I salute you, sir. Well, we are talking about degenerate forms of matter. The degenerate neutron form of matter, that is the neutron star, can itself be described as being the most perfectly homogeneous form of matter. In every location within a neutron star, we find ourselves inside the volume of a neutron. Firstly, we note that the mass energy density of each neutron is exactly the same, 939.565 mega electron volts. Secondly, we know from the Pauli exclusion principle that every neutron within the neutron star occupies a unique state, or rather volume of space. Thus, the mass energy density in the neutron star can be said to be perfectly homogeneous. Now, it is the greater part of wisdom within me that recognizes the fact that the vast majority of theoretical cosmology is built upon the sacred principle that the universe is homogeneous and isotropic. The quantum fluctuations of inflation theory introduces perturbation into such a description of perfect homogeneity that the very brightest minds build their life's work upon such a description. The volumes of literature and research of the cosmological community as a whole is testament to this fact. But more disgracefully is that anyone who argues or provides a counter-argument will most likely be excommunicated, having their funds cut off and exiled in the homogeneity of thought that are university campuses, who all in unison cry, "Diversity is our strength," and for that I am eternally grateful. For myself, I have only a very shallow understanding of the mathematical descriptions used. I may have only got a second honours degree in computer science and mathematics, but most of that was down to wanting to understand functional analysis, as well as having an obsessive coding project that I called Black Omega. I love mathematical proofs, and functional analysis truly taught me the ways of abstract and lateral thought from the best minds history has ever seen. So I understand the beauty and attraction. But a key question I remember thinking about at the time was, what exactly is a physical dimension? Glad I kind of managed to work out an answer to that one, in seeing the interweave of spatial and time geodesics, the fundamentals of nature in describing a field. I did not understand the importance of learning functional analysis at the time, just that it was beautiful and extremely challenging. It opened my mind to a much larger universe of abstract thought. It has only been in living a life of applied application, mainly as a software engineer developing numerous scientific models, that I came to understand its actual real-world applicational use. In particular, I saw the implicit language of mathematical analysis in developing cosmological models. In thinking about describing the Big Bang by way of a kilonova event, the merger of two neutron stars of the Superverse, I am suddenly able to provide my model with a perfectly homogeneous form of matter. That is, I now have initial conditions which are very similar to the starting description given by inflation theory. This is in opposition to my Big Bang Hypernova hypothesis, whose starting state is a hypernova event inside the Superverse. My reasoning for arriving in a mostly homogeneous state comes from my argument that the matter that falls into the newly born rotational black hole is effectively being blended inside nature's ultimate blender before being ejected out via the entrapped white hole. Then in turn, the ejected jetiverse is itself being shaped by the solenoid-shaped field generated by the magnetohydrodynamic rotation of plasma. This in turn effectively creates a reverse-timed vortex of irrotational flow as it is ejected from the white hole, thus mixing the mass-energy density even further until it is all homogeneous. But it is in the anisotropies of the cosmic microwave background radiation that is the primary reason for putting the Big Bang Kilonova Hypothesis, whose model it is my objective to formulate. Of course, if you fancy a crack at the title, be my guest. You'll save me a lot of mathematical work, as my mind screams the quote.
A battle log! A battle log is coming! The scourge of our people during flame!
Now I understand. What an evil fortune. And I am already weary.
Over the bridge! This is a foe beyond any of you. I must pull the narrow way. Fly!
Now, without the work laid out in developing my hypothesis around a hypernova, I would never have invented the concept of the Superverse. I first had to imagine a massive undefined star-like object that I subsequently called a McLean, whose mass and size was sufficiently large enough. The spherical Bianchi supervoid gave me rapid vision with respect to trying to imagine such a thing. Thus, from imagining hypernova over McLean, giving birth to a black hole in the Superverse, so too am I able to use the exact same explanation to getting Neutron Star in the Superverse. So rather than my hypernova collapsing into a black hole, it rather collapses into a neutron star. Thus, I am able to explain how and why these neutron stars of the Superverse came into being before giving rise to the Big Bang Kilonova event itself. The primary reason for suddenly changing my mind in using a kilonova as opposed to a hypernova as the basis for describing the Big Bang event is because of the shape and structure of the large-scale anisotropies found in the cosmic microwave background radiation. Specifically, there are two spiral-shaped anisotropies, one hot and one cold, whose central locus points are centered upon the cold spot. In fact, the central locus point of the cold anisotropic spiral is the cold spot, the Eridanus supervoid itself. The central locus point of the hot anisotropic spiral is directly adjacent to the cold spot. From these central locus points, both the cold spot and the adjacent hot spot, we can see the formation of two spiral arms sweeping out and around, encompassing the entire southern hemisphere of Planck's high-resolution map of the cosmic microwave background radiation. Now, this is not very evident from the flat maps employing a Molly-Weld projection of the microwave sky because the details of these features are obscured by the flat projection of the map, coupled with the fact that the cold spot is in the southern polar region. Just think about the shape of the continent of Antarctica on flat maps. Does it look like how Antarctica actually appears on a spherical atlas? By mapping the Molly-Weld projection of the published map onto a sphere, using a bit of old-school WebGL programming, I have created a 3D viewer by which we can see these spiral structures much more clearly. Specifically, the image shows an orthographic projection looking directly down upon the South Pole of the map published by the European Space Agency from the Planck mission, in which the anisotropies, or anomalies as the ESA call them, have been enhanced. On the South Pole, we clearly see two lobes, one hot and one cold, following the two arms, one hot and one cold, of the anisotropies, which both spiral outwards from these central locus points, namely the CMB cold spot and what I have called here the CMB hot spot. As yet again, I need to find name and description for the important features that have been effectively cleaned, an issue we'll talk about in a second. In considering this pattern of two very specific and distinct spiral arms, I suddenly saw the imprint of the same pattern seen in the gravitational waves formed by the merger of two neutron stars, a kilonova event. Thanks in large part to the entire LIGO community, and in particular the SXS collaboration, we have animations showing the pattern gravitational waves form in the merging of two neutron stars. Namely, we see a pattern of two spirals whose central locus points are adjacent to the other. Each spiral mirrors the other as each follows a rotational spiral path out and away from these central locus points. This is the exact same shape and pattern we see in the anisotropies of the microwave sky. Now, back when I originally defined the superverse for the first time, I did make note that it may not have been a hypernova that was responsible for the Big Bang event itself. Specifically, I said, in fact, it may not have been a hypernova of McLean's star-like object that caused the Big Bang. The main point of my idea is a single event caused two CPT symmetric output jets, each traveling away from one another in polar opposite directions. So another kind of event that produces a pair of gamma ray bursts, like a hypernova, is the collision of two neutron stars merging to form a black hole. Well, the anisotropies of the cosmic microwave background sky show two spiral arms, each being a mirror with respect to the other, spiraling outwards from two adjacent lobes. One of those lobes being the cold spot, which from my point of view of my hypothesis is a massive point of validation. Specifically, I have argued from the beginning that our Jetaverse's overall direction of travel is away from the gravitational singularity, the space that opens up between the white hole and the mass it ejected, which is the actual Big Bang event itself, comes to form the Eridanus supervoid. Thus, in seeing the high-resolution map of the anisotropies being centered upon the cold spot is validation of this idea. And so, because the primary evidence, the microwave anisotropies, show the same pattern as the gravitational waves coming from the merger of two neutron stars, I am changing the entire underlying basis for my hypothesis about the Big Bang. Namely, it is no longer called the Big Bang Hypernova Hypothesis, but the Big Bang Kilonova Hypothesis, because I, being an actual scientist who follows the evidence as opposed to hiding it or cleaning it. Like free markets, it is the beauty of the scientific method in that it is self-correcting, as opposed to the expert communist view preached upon university campuses, no matter how many deliberately forgotten genocides lie in their wake. After all, it took a clinical psychologist to educate an entire generation about Holodomor.
So then 6 million Ukrainians starved to death in the 1920s, which is something you never hear about, right? You never hear about that. Why do you never hear about that? That's a question worth asking. You know, it was an absolute catastrophe. They used to, so these people were starving, right to the point of cannibalism, right? I mean, it was ugly as anything you could possibly imagine.
As opposed to the humanities and history departments, who seem only able to bang on about the importance of skin colour. Living by the edict that skin colour only becomes a problem when someone makes it a problem, I have watched the entire establishment bang on and on about it for the last decade until it is now a massive problem. Well...
Which month is White History Month? No, come on, tell me.
Well, I'm Jewish.
Okay, which month is Jewish History Month?
There isn't one.
Oh, why not?
Yeah.
Do you want one?
No.
I don't either. I don't want a Black History Month. Black history is American history.
How are we going to get rid of racism?
Stop talking about it. I'm going to stop calling you a white man.
Yeah.
And I'm going to ask you to stop calling me a black man. I know you as Mike Wallace. You know me as Morgan Freeman. You're going to say, well, I know this white guy named Mike Wallace. You know what I'm saying?
Problem. Well, let the following be a humble reminder about who exactly is really in charge. Fractal geometry is the cosmological principle, and thus self-similar patterns repeat themselves irrespective of scale. Now, we have just seen how two large-scale anisotropies, one hot and one cold, form a two-arm spiral pattern out and away from a central locus point. This image here is NASA's image map of our own Milky Way galaxy. Note how in our own Milky Way galaxy there are two main spiral arms arising from either end of the core ellipsoid called the galactic bar. Namely, we have the Scutum Centaurus arm and the Perseus arm. So the very structure of our own Milky Way galaxy has the same pattern seen in the large-scale anisotropies. Now, ask yourself, or anyone for that matter, does the philosophical principle that, at the larger scale, the mass-energy density of the universe is both homogeneous and isotropic, have any real-world bearing upon your overall worldview? Fractal geometry is a cosmological principle, and the very embodiment of that principle is mirrored in the ancient Chinese dualist symbol of yin and yang. Now, as I have fully covered beforehand in this podcast in deriving my definition of the Superverse, we saw how a rotating black hole gives birth to a white hole, which in turn gave birth to our very universe. This central pattern of creation itself, as truthfully revealed by the laws of general relativity, arising from the collision of two superneutron stars, is best given symbolic form in the symbol of yin and yang. This twin-lobe central structure we see mapped on the microwave sky as being a direct mirror image of the very yin and yang symbol. The very code names I gave my projects, namely Black Omega and then Alpha White, are to me the very imprint of this symbol. I called my music player Black Omega because I just thought it was a cool sounding name at the time in the mid-1990s. I named the Big Bang Kilonova Hypothesis by the codename Alpha White, primarily in complete mirror opposition to Black Omega being the second chapter of my life. The Pacific Day being the very day my daughter was born, so too was Alpha White born. Behind this was a vision so deep and spiritual that I saw the very separation of light and darkness, night and day. The only true way I feel I can vernacularize this vision is to take the book of Genesis of the Bible and give my interpretation of it, and I'm not laughing or poking holes at it, which I hope to do in the next podcast. After all, this is the Big Bang Kilonova Hypothesis podcast, and I want to get on to talk about the afterlife inside the one electron universe. But for this podcast, I wish to turn back to the issue I have with modern cosmology in creating clean maps of the microwave sky. As any good scientist would tell you, the first thing you should do is to test your assumptions. Hence the demonstration of showing that fractal geometry is the cosmological principle, and this principle runs so deep that I can talk about it in terms of the story narrative of my life. On the other hand, I certainly feel that given the standing cosmological principle of homogeneous and isotropic conditions has no bearing on my life, but thankfully I'm not a tenured academic who has to toe the line such that virtue-signaling narcissistic politicians can maintain a consistent story narrative of constant fear and crisis within the media. Rather, I am a man led by philosophy and the scientific method precisely because what I desire above all else is to understand the truth of nature, not because I am simply told to do so. So were the cosmologists who predicted and discovered the microwave background radiation. The tale of the horned antenna speaks for itself, and to be fair, so are the vast majority of cosmologists who conduct practical work. However, theoretical abstractions built upon false claims of accuracy have led us into the desert of superstring theory and its multiverses. So too has the production of clean maps of the microwave sky been leading us away from seeing the truth which has always been in front of our eyes, the yin and yang dualism of life. It's what led to this state of affairs. The first key assumption is embodied in the cosmological principle that the universe at the larger scale is both homogeneous and isotropic. Hence, cosmologists expected the afterglow of the Big Bang event, the yet-to-be-discovered microwave sky, to be both homogeneous and isotropic. When the microwave afterglow of the Big Bang was first observed and measured in 1965 by Wilson and Penzance, this is exactly what was found. Namely, they observed that the temperature of the afterglow was completely uniform from every heavenly direction, and thus this was positive confirmation that at the larger scale the universe is both homogeneous and isotropic. However, with the development of more precise instrumentation, methodologies, and measurement, fluctuations within the microwave sky were discovered. Of particular note is the Cosmic Background Explorer satellite, more commonly known by its acronym COBE, which was launched in 1989 in order to map the microwave sky. Following a 4-year mission, COBE mapped the microwave sky from 1989 to 1993. The surprise for cosmologists came with the discovery of what is now called the CMB dipole anisotropy. Now, in order to talk about the various resultant maps of the microwave sky, we have to talk about multipole expansion. In order to create a map of the entire heavenly sphere, satellite missions like COBE, WMAP, and Planck are designed to sample photons coming from the now microwave sky from every single direction. Effectively, the flight path of the satellite is designed to rotate in such a manner that over the course of the mission its sensor ends up being pointed in every heavenly direction. For each photon sampled, there is a corresponding measurement recording the direction from which that photon came. Thus, for each photon of the microwave sky sampled, there is a corresponding set of spherical polar coordinates related to the region of the sky from which it came. A multipole expansion is a function written as a mathematical series, most commonly as a sum of spherical harmonics, where that function is dependent on angles. It is employed as an analytical tool where the collected data can be mapped onto a sphere, such as is the case for mapping the cosmic microwave background radiation. The maps produced from multipole expansion are dependent upon the number of sums in a given series. The greater the number of sums used in expressing the function, the higher the resultant resolution of the map, as finer angular features are revealed. However, the higher the resolution of the resultant map, the greater the number of data samples required. This is evident in the number of samples collected between the subsequent missions of COBE, WMAP, and Planck, which in turn produce higher resolution maps. This resolution of the multipole maps is expressed in terms of progressively finer angular features or moments. The first term in the summation is called the monopole moment, the second term is called the dipole moment, the third the quadrupole moment, the fourth the octupole moment, and so on. A multipole moment usually involves powers and is expressed in terms of 2 to the n, where n is a positive integer. In returning to discussing COBE and the CMB dipole anisotropy, the map produced showed a mean temperature of 2.725 Kelvin with a variation of 0.0035 Kelvin. This tiny variation was significantly separated into two distinct lobes. The center of the cold lobe is in the direction of Aquarius in the southern hemisphere. The center of the hot lobe is in the direction of the constellation Leo in the northern hemisphere. A very significant feature about COBE's CMB dipole map was the unusual alignment that these two hot and cold lobular structures have to the ecliptic plane of our solar system. This improbable alignment between our own solar system's ecliptic plane and this observed large-scale structure visible in the CMB dipole map is problematic to say the very least. It is problematic because it flies in the face of the long-held Copernican principle, which states that humans on the Earth or in the solar system are not privileged observers within the universe. This philosophical view is in complete opposition to placing Jerusalem at the very center of all creation, meaning Earth is not the center of all creation, and nor is our Sun, and nor is our Milky Way galaxy or the local group cluster to which our galaxy belongs. Thus it implies that the orientation of the solar system and direction of travel through the Milky Way should be completely random with respect to the rest of the universe. Thus this unusual alignment of our solar system's ecliptic plane with respect to the CMB dipole anisotropy is problematic so much that it earned the nickname the axis of evil, after President George W. Bush's 2001 State of the Union speech. To many physicists, this result of COBE was not so much a surprise but confirmation of ground-based measurements from the 1970s and 1980s. Arising from numerous observations and results, astronomers had determined that our solar system, along with the Milky Way galaxy, are traveling with a speed of 600 kilometers per second in the direction of what is now called the Great Attractor. The Great Attractor itself is located in the constellation of Leo, which is the central location of the hot lobe of the dipole anisotropy. Thus it was concluded that the CMB dipole arises from a Doppler shift effect because of our solar system's speed and direction of travel with respect to the rest of the observable universe. In effect, we observe the microwave light coming from the region of Leo as being compressed or blue shifted because of our movement towards the direction of Leo. Vice versa, as our solar system is moving away from the constellation of Aquarius, where the cold lobe is located, microwave light coming from that region is stretched or further redshifted. Thus we see this shifted light as having a Doppler shift and the reasoned underlying explanation for what was the cause of the CMB dipole. Because of this Doppler shift, arising from our solar system's movement with respect to the rest of the universe as a whole, reasoned explanation as to the cause of the CMB dipole anisotropy was given. Given that the CMB dipole anisotropy is due to local conditions as opposed to being an actual structure of the CMB, then in order to produce the maps of the microwave sky, this anisotropic effect needs to be removed or cleaned. It is this act of effectively removing these large-scale anisotropies from the final map that is referred to as creating a clean map. However, the problem of what exactly these large-scale anisotropies actually are had only just begun. Launched in 2001, NASA's Wilkinson Microwave Anisotropy Probe, WMAP, looked to map the temperature variations of the CMB with even greater precision than COBE. Again, the CMB dipole anisotropy was detected, but it was in the development of the quadrupole and octupole maps of the CMB that the mystery of the large-scale anisotropies deepened. In the dipole, we had a series of two lobes, one hot and one cold. The quadrupole map in turn shows a series of four lobes, cold, and hot again. Again, curiously enough, there is an alignment with the ecliptic plane of our solar system. These structures having been identified after taking the Doppler shift into account and the subsequent maps cleaned. Then, with the octupole map, a series of six lobes are seen, cold, and hot again. Again, the same alignment with the ecliptic plane of our solar system is seen. The European Space Agency's Planck mission operated from 2009 to 2013, which again had the same mission as WMAP and COBE, which was to map the anisotropies of the microwave sky. The same large-scale anisotropic globes were again found in the quadrupole and octupole maps, thus reproducing the same unexpected result. With further resolutions, these large-scale structures gain further and further detail, such that the map I have used here in describing the Big Bang Kilonova Hypothesis is the highest resolution map produced by the ESA Planck mission, where these large-scale anisotropies have been enhanced. Now, this is in opposition to the more commonly seen high-resolution map, where these large-scale temperature fluctuations have been cleaned. It is this cleaning or effective suppressing of the evidence that I personally have a massive problem with. For a long time now, I have been wondering about the cause of these large-scale anisotropies. On the one hand, I think it's very fair to clean the maps such that it removes any residual Doppler shift, but on the other hand, I feel the evidence is being suppressed because ideologically it does not fit the narrative. The narrative being that at the largest scale the universe is both homogeneous and isotropic. Since there was so little temperature variation found in the microwave sky at first, this position has become entrenched. As the large-scale anisotropies could initially be explained in terms of arising from a Doppler shift effect, then it was simple enough to ignore them. Or rather, I think in terms of scientific consensus, a unified front of showing a clean map of a homogeneous and isotropic universe was given. From my perspective, being outside the cosmology community, I never really ever heard discussion or speculation about their nature, and this vexed me.
It vexes me. I'm terribly vexed.
However, given the nature of my original idea, I was forced to start digging into the literature, and certainly the last number of years has been a crash course in cosmology. Didn't really expect to end up crashing the entire science of cosmology into a cliff face, but hey, that's ancient symbology for you. Certainly gives a new spin on the popularity to Dan Brown's Da Vinci Code. You think it's a coincidence? It's not, and Harry Potter is semi-autobiographical to me. I have the scars to prove it. One primary example of how cosmologists look to explain the large-scale anisotropies comes with the development of Bianchi Universes. To quote the Scholarpedia description, Bianchi Universes are the class of cosmological models that are homogeneous but not necessarily isotropic on spatial slices, named after Luigi Bianchi, who classified the relevant three-dimensional spaces. They contain as a subclass the standard isotropic models known as Friedmann, Lemaitre, Robertson, Walker, FLWR universes. Calculations of nucleosynthesis and microwave background anisotropies in Bianchi models have been compared against data from the real universe, typically giving null results which can be translated into upper limits on anisotropy. Tentative detections of non-zero anisotropic shear by Jaffe et al. 2005 are currently inconsistent with other known cosmological parameters, Planck collaboration et al. 2015, and with polarization of the microwave background, Ponset and Chandler 2007. However, the models remain widely studied for their pedagogical value. Homogeneity in space implies that Einstein's equations reduce from partial to ordinary differential equations in time, making them tractable exact solutions of Einstein's field equations. End quote. The sentence from rereading that description, tentative detections of non-zero anisotropic shear by Jaffe et al. 2005 are currently inconsistent with other known cosmological parameters, Planck collaboration et al. 2015, and with polarization of the microwave background, Ponset, Chandler 2007. The reason for this, as we'll discuss later on, is that it references the work of T.R. Jaffe. I make very specific reference to Jaffe et al. 2005 paper, Evidence of Vorticity and Shear at the Large Angular Scale in the WMAP Data, a Violation of Cosmological Isotropy, in which they specifically reference a Bianchi Type 7H model universe. The reason I reference this paper very specifically in my essay General Relativity and Rotation is because a Bianchi Type 7H model universe is a universe that is rotating. From the point of view of the Big Bang Kilonova Hypothesis, a rotating universe makes sense. Specifically, in my General Relativity and Rotation essay, I extrapolate Roger Penrose's idea of entrapped spacetime and positive curvature. This extrapolation we have just covered here in this podcast, such that sufficient reason was given in defining the superverse. Although I highly recommend you read my General Relativity and Rotation essay, in which I fully try to lay out my entire reasoning. At the center of my explanation for the Big Bang Kilonova or Hypernova hypothesis is the idea of a rotating black hole being born inside the superverse. The importance rotation plays comes in studying the anatomical structure of a rotating black hole as described by the Kerr metric. Specifically, we see how an entrapped wormhole opens up within the bounds of the ringularity. This entrapped wormhole in turn leads to the outflow via a rotational white hole, in whose birth two parallel universes are born. Given the white hole is rotating, and thus has an inverse ergosphere, the outflow of spacetime from it will also be rotating. Thus, rotation is imparted to the universe from the moment it was born. So from the point of view of a stationary observer inside the parent universe, the child universe is rotating. As an example of this, we see the rotational helical spiral path traced by various subverses within our own Milky Way's galactic core. With respect to the rotation of our own universe, it would be seen to be rotating with respect to a stationary observer inside the superverse. So in effect, rotation is king when it comes to my hypothesis. The idea of a rotating universe was first given form by Kurt Gödel in presenting his solution of Einstein's field equations via the subsequently named Gödel metric. In studying the effects of a rotating universe with respect for how to account for the formation of the CMB anisotropies within a homogeneous universe, we have the development of various Bianchi cosmological models. Specifically, I make reference to work of both Jaffe et al. 2005 and the subsequent reproduction of this work by Jason McEwen. However, before I go on to describe this work, we need to visit the evidence that shows that the CMB large-scale anisotropies are in fact linked to the rotation of the universe as a whole. In what I consider to be probably one of the most important pieces of cosmology is Lionel Shamir's paper published in November last year, because it shows the same dipole and quadrupole maps in considering the asymmetry in the spinward direction of spiral galaxies. The arms of a spiral galaxy, when viewed from above, are either spiraling in an outward clockwise direction or outwards in an anti-clockwise direction. So in looking out into the universe and observing a spiral galaxy, we either see its arms with either a clockwise or an anti-clockwise spinward direction. This binary observation of a spiral galaxy having either a clockwise or anti-clockwise spinward direction is what Lionel Shamir used in studying and mapping the spinward asymmetry of spiral galaxies. As a side note, in order to shatter your sanity, the specific binary choice between a clockwise spiral and an anti-clockwise spiral can be seen encoded both on my inspirational artwork and upon the top of ancient Roman columns. Remembering that fractal geometry is a cosmological principle and that self-similar patterns repeat themselves irrespective of scale. For my part, I cannot help but draw the parallels given that it makes for the telling of a wondrous tale. Lionel Shamir's work was to effectively measure the observed asymmetry of spiral galaxies. Effectively, he developed an image recognition algorithm that when shown a picture of a spiral galaxy would allow it to determine if its arms had either a clockwise or anti-clockwise spinward direction. Using datasets of images of spiral galaxies from both Pan-STARRS and the Sloan Digital Skies survey, he employed his algorithm to find their respective spinward direction. With the Sloan Digital Skies survey dataset, he identified 88,273 galaxies with a clockwise spinward direction and 86,075 galaxies with an anti-clockwise spinward direction. From the Pan-STARRS dataset, he identified 16,508 galaxies with a clockwise spinward direction and 16,520 with an anti-clockwise spinward direction. Now, given the cosmological principle that the universe is both homogeneous and isotropic at a sufficiently large enough scale, we would expect there to be no asymmetry between the number of spiral galaxies with clockwise and anti-clockwise spinward directions. That is, we would expect a fairly 50-50 or half-and-half split, and overall, when considering the entirety of the two datasets, this is what we see. But by the same assumption that the universe is homogeneous and isotropic, it would also mean that given any region of the night sky and counting the number of galaxies clockwise and anti-clockwise spinward directions, we would expect the numbers to be both the same. Thus, I would expect symmetry in the numbers regardless of the region or sky in question. That is, there should be about the same number of clockwise spinward spiral galaxies as there are anti-clockwise spinward spiral galaxies within a given fixed region of the sky. What Lionel Shamir found was that for certain regions of the heavenly sphere, there was a statistically significant asymmetry between the number of clockwise and anti-clockwise spinward spiral galaxies. Employing the same kind of multipole expansion analysis as we discussed for the microwave sky, Shamir produced a number of multipole maps showing the value of sigma, the standard deviation, in terms of comparing different pairs of galaxies and showing this asymmetry. The dipole map from figure 5 shows sigma of possible dipole axes in all combinations of alpha, delta coordinates using the spin directions of Sloan Digital Sky Survey dataset. In more plain English, this map of the dipole expansion shows the variation between the symmetry and the asymmetry of spinward directions covering all the night sky. What is immediately apparent is that this map has the same shape with two lobe structures as the CMB dipole. Looking at figure 10, we see the dipole map for those galaxies coming from the Pan-STARRS dataset. Again, we see two lobes, but they are more aligned with lobes found in the subsequent quadrupole maps. Figure 11 and 12 from Shamir's paper shows the quadrupole maps showing the asymmetry in the spinward direction of galaxies, both for the Pan-STARRS and the Sloan Digital Sky Survey datasets respectively. Again, we can see that the shape and structure of these maps is a match to the four lobes found in the quadrupole map of the cosmic microwave background radiation. To quote from the conclusion, "The highest probability was achieved when fitting the distribution of galaxy spin with directions to quadrupole with probability greater than 6 sigma." Another quote from the conclusion says, "Since the spin patterns of a galaxy as visible from Earth is also an indication of the actual spin direction of the galaxy, the large-scale patterns in the distribution of the spin directions can be an indication of a rotating universe." In effect, we can see that the dipole map of asymmetry between galaxies with opposite spins matches up with the CMB dipole. In turn, we can see both of the quadrupole maps of asymmetry in the spinward direction of spiral galaxies matches up with the large-scale anisotropies of the quadrupole maps. Thus, it is very reasonable to conclude that the cause of the large-scale anisotropies is because of the rotation of the universe as a whole. In fact, I would go further and say this effectively looks to nullify the explanation that the Doppler shift is the cause of the CMB dipole. Given that the observed spinward direction of a galaxy is not a local phenomenon, and that the subsequent dipole map matches the CMB dipole map, it effectively nullifies the standing explanation of the CMB dipole being caused by a Doppler shift. Hence, it becomes absolutely imperative to rework the various maps of the CMB such that actual values of the CMB dipoles are not removed or cleaned. Meaning, the current maps of the CMB are not valid because the CMB dipole variation has been removed, when in fact the CMB dipole variation is a very important feature coming from the cosmic microwave background radiation. That's the great thing about science, in that it is self-correcting. It may come up with explanations that are completely reasonable and sound, only later to be completely overturned because further evidence and experimentation has shown that the assumption was in fact wrong.
An Bell, der unter Benutzung empfindlicher Kontakte mit seinem Mikrofon zuerst Schallschwingungen in variable elektrische Ströme verwandelte. Denkt auch an Maxwell, der die Existenz elektrischer Wellen auf mathematischem Wege aufzeigte. An Hertz, der sie zuerst mit Hilfe des Funkens erzeugte und nachwies. Gedenket besonders auch Liebens, der in der elektrischen Ventilröhre ein unvergleichliches Spürorgan.
This case, specifically of the CMB dipole, I feel will become a testament to that truth. But for myself, in relation to my Big Bang Kilonova hypothesis, this really is the best news for me as I imagine my arms in the air doing my lap of victory, or as I casually put it, This in effect shows that the large-scale anisotropies of the microwave sky are related to the entire rotation of the universe. But before moving on to the aforementioned Bianchi Universes, indulge me in a small thought experiment, as it really bugs me that our universe has this unusual and improbable alignment, and the question why, I believe, is a very fundamental one. Though, as an addendum, before proceeding to explanation by way of a divine creator, I do not make such an argument without justification or cause. The very mention of such is enough to turn many a brilliant scientific mind off and away. Of such, I count my own self in such regard as the emotional reflex envisioning evangelicals and their very literal interpretation of Genesis in the face of evolution is invoked. My justification, however, comes because behind the birth of the Big Bang Kilonova Hypothesis is the symbology of the artwork inscribed upon the two ossuaries that bear the name Caiaphas, and to my eyes it is the most perfect map of creation. So perfect to my eyes are each of these two pieces of work that they take pride of place in each piece of work I have set forth about my hypothesis of the Big Bang, as I continually draw inspiration from them. But yet, the old man enshrined in the ornate concentric ringed ossuary, specifically identified as Joseph ben Caiaphas, history remembers as the villain who sent Jesus of Nazareth to the cross. And it is a simple fact that Christianity names Jesus as being God, or the Son of God. Between this reality and myself explaining my life's internal story narrative to myself, that leads me to being able to defining God in the context of science, which will be the focus of my next podcast. But for now, indulge this simple thought experiment as I wish to open a window into my soul and way of thinking. Just imagine for a moment you're a cosmic level being who, like a gardener, is looking to plant a new garden. But rather than an acre-sized garden, the garden itself covers an entire solar system. Just like we take great care in choosing the perfect geographical location in looking for a place to call home, so too does this cosmic level Q-like being knows what makes for an excellent garden, i.e. finding a plant where basic singular cellular life has taken hold, having been seeded via panspermia process. Now, given that a precondition for the successful evolution of complex multicellular life is that the solar system has its unusual alignment to the flow of our jetiverse itself, it would imply that the solar system was a perfect place to evolve the template of man. Why exactly this is a precondition does really become a question. One answer might lie in the alignment of sub-jetiverses born from the black hole inside our own universe. There is an idea that supernova, and particularly the gamma-ray bursts from a hypernova, could have been responsible for massive extinction-level events upon planet Earth. Having the alignment that our solar system has may decrease our chance of us being in the line of fire of a gamma-ray burst. But as a counter-thought to that idea is the presence and orientation of Eta Carinae. Or maybe this alignment was a precondition such that our hypothetical being could know everything about the wave function of the solar system. One thing I can say for certain is that when it comes down to the story of how we discovered the true significance of large-scale anisotropies and how I've linked them to the Big Bang Kilonova Hypothesis, all I can say is I just could not resist employing my so-called inspirational symbolic artwork in explaining the binary distinction of the spinward direction of spiral galaxies. That, as well as using it to also show the nature of a spiral pattern in describing the spiral anisotropies in towards the CMB cold spot. There is a strange beauty in the telling of that tale. On the other hand, it only cost me by frying out my entire nervous system. In describing Bianchi Universes earlier, we saw how cosmologists have tried to make sense of the anisotropies seen in the microwave sky. Specifically, they describe a universe that is homogeneous but not necessarily isotropic. Standard cosmological models assume that the universe on cosmological scales is both homogeneous and isotropic in conforming to the standard cosmological principle. If the assumption is relaxed so that the former condition holds but not the latter, then the allowed solutions of the equations of general relativity are called Bianchi Models, after the Italian mathematician Luigi Bianchi, 1856 to 1928. Luigi Bianchi created a classification of all three real dimensional Lie algebras which contain 11 different classes. The particular classification, given a rotating universe, is the Bianchi type 7H models as studied by Jaffe et al. And Jason McEwen et al. Now, with respect to the anisotropies, we know that they are linked to the large-scale rotation of the universe as a whole, as we've just seen, in respect to Line and Schmier's work. So with respect to Jason McEwen's comments about the model not fitting with standard cosmology, namely the Lambda CDM model, is fair. However, the Big Bang Kilonova Hypothesis is a completely new cosmological model. A component that is not part of my model is in defining the effects of dark energy upon the Big Bang event itself. Specifically, dark energy is matter that belongs to the surrounding superverse. Our universe, as we discussed, comes from extending Roger Penrose's idea of entrapped spacetime with positive mass. As dark energy can be said to be negative mass having an anti-gravitational effect, it is important to note that this is matter outside the veil of our own entrapped universe. This comes particularly from my description of how the Bianchi supervoid formed, coming from a star inside the superverse. Effectively, dark energy is causally disconnected from us, being inside our own entrapped universe. In turn, dark matter is matter that has been causally disconnected from our universe, having fallen into a black hole and injected out into a sub-jetaverse, inside the confines of our own universe. I particularly mention dark energy and give it context here, because from looking at the literature for Bianchi Universes, I get the feeling that many cosmologists are not considering Bianchi models as being viable or arising from the need to account for dark energy in their cosmological models. From the point of view of the Lambda CDM model, dark energy is a major component that is a part of its Big Bang model, particularly in putting forth the mathematical hack that is inflation theory. But I have really come to consider some of the thinking behind the Lambda CDM model to be very lazy. Find a new form of matter and, well, simply just add it into the mix. When dark matter was discovered, the solution to the Big Bang model was simply to add it into the pot. Then again, when dark energy was discovered, the same solution in just adding it to the pot, even if it now forms more than 3/4 of the ingredients, just so long as the consensus is maintained in the Lambda CDM model and all supporting literature, which is virtually all of the cosmological literature, does not need to be rethought and rewritten. And for that I am really truly grateful. The Big Bang Theory is a prediction of general relativity, and by general relativity we have seen it give birth to the Big Bang Kilonova Hypothesis. The Lambda CDM model looks to explanation by way of quantum theory, where general relativity is reduced to a dimensionless scale factor, such that experiments in particle accelerators are used to divine the way. Fractal geometry is the cosmological principle, and the self-similar pattern of a spiral galaxy and its associated Fermi bubbles is also seen in the atomic orbitals of the electron in a hydrogen atom, and for the exact same reasons, entrapped bubbles of spacetime coming from the field whose structure is formed from the interweaved spatial and temporal geodesics. To quote from the abstract of Jaffe et al.'s paper entitled "Evidence of Vorticity and Shear at the Large Angular Scale in the WMAP Data, a Violation of Cosmological Isotropy." To quote, "Motivated by the large-scale asymmetry observed in the cosmic microwave background sky, we consider a specific class of anisotropic cosmological model, Bianchi type 7H, and compare them to the WMAP first year data on large angular scales. Remarkably, we find evidence of correlation, which is ruled out as chance alignment at the 3 sigma level. The best fit Bianchi model corresponds to x equal to 0.55, omega not equal to 0.5, a rotation axis in the direction L, B equal to 222 degrees, minus 62 degrees. Shear is equal to 2.4 times 10 to the minus 10. And the right hand vorticity, omega, equals to 6.1 times 10 to the minus 10. Correcting for this component greatly reduces the significance of the large-scale power asymmetry, resolves several anomalies detected on large angular scales, i.e. the low quadrupole amplitude and the quadrupole octupole planetary and alignment, and can account for a non-Gaussian cold spot on the sky. Despite the apparent inconsistency with the best fit parameters required in inflationary models to account for the acoustic peaks, we consider the results sufficiently provocative to merit further consideration." End quote. So basically, a best fit model considering the rotation of the universe minus inflation shows a vortex nature centered upon the cold spot of the CMB. And what could possibly give birth to our universe, which arises from a vortex? Simple, a rotating white hole, which is effectively a time-reversed black hole. In fact, water vortices are actually used as analog models of rotating black holes. Thus, we find the simplest explanation to why our universe was born. Namely, our universe was born from a rotational white hole in the region that would come to be called the Eridanus supervoid, as evident by the large-scale anisotropies of the microwave sky. The imprint of 2 spiral curves being the full large-scale anisotropies also in turn tells us exactly how and why this rotational white hole suddenly came into being 13.8 billion years ago. The reason being that a rotational black hole was born in the Superverse, arising from the merger of 2 neutron stars. The importance of Jaffe's work in finding a best fit Bianchi model in relation to my Big Bang Kilonova hypothesis is multidimensional. Firstly, from my understanding, Jaffe's model of a Bianchi type 7H universe is the only one, or one of the few, Bianchi models that actually matches up with the anisotropies seen in the WMAP data. Specifically, to quote Scolopedia, calculations of nucleosynthesis and microwave background anisotropies in Bianchi models have been compared against data from the real universe, typically giving null results, which can be translated into upper limits on anisotropy. This before it then goes on to specifically cite Jaffe's 2005 paper. Of course, it is very important to bear in mind how I have defined dark energy in the context of the Big Bang Kilonova hypothesis. Dark energy is not a component of a Bianchi type 7H model. On the other hand, there is the discussion in the source I cite which talks about Jaffe's best fit model as being a null result precisely because dark energy is not a component. From the point of view of the Lambda CDM model, dark energy is a component of and inside the Big Bang event itself, as expressed by inflation theory. As Jaffe's model does not have this dark energy component, they consider it to be a null result. But in the Big Bang Kilonova Hypothesis, I specifically define dark energy as being outside and separate from the Big Bang event itself. Namely, I define dark energy as being that mass energy density which belongs to the superverse, thus rendering this point mute. The second reason for its importance is that it specifically considers a rotating universe which, as we've discussed, is a critical factor. Namely, the Kerr metric of a rotating black hole gives it a structural anatomy such that an entrapped wormhole is formed, which in turn leads to a rotating white hole and the twin pair of child vertices it gives birth to. As rotation is imparted to our universe, as evident from Lionel Schmier's work of spinward galaxy asymmetry, then we need a model that considers rotation, and Jaffe's best fit model fits the bill. The third reason comes in considering the outflow from a rotational white hole. As water vortices are effectively analog models to rotating black holes, coupled with the notion that a white hole is a time-reversed black hole, then we would expect its outflow to be analogous to a time-reversed vortex. Coupled to this, we observe rotational shear of water as spiral waves flow over each other as they spiral down the drain. Jaffe et al. 2000 paper specifically states evidence of vorticity and shear in the very title of their paper. The fourth reason is that Bianchi Model Universes specifically considers the birth of a homogeneous universe, but one that is not necessarily an isotropic one. As the Big Bang Kilonova Hypothesis begins its description in defining two neutron stars belonging to the superverse, the most perfectly homogeneous form of matter within the superverse, then we have satisfied the critical condition that the universe being born is homogeneous. In totality, Jaffe et al. 2005 best fit Bianchi Type 7H model is the closest actual cosmological model that exists whose findings are in line with the Big Bang Kilonova Hypothesis. Further to this, Jaffe's results have been reproduced in turn by Dr. Jason McEwen and colleagues at the University College London in specifically asking the question, is the universe rotating? Having now laid out my full argument and gone into details of both the theoretical and observational elements, I can now finally tell the tale told by the Big Bang Kilonova Hypothesis. Our story begins with the death of a massive star, McLean, belonging to our 2B parent universe, the Superverse. This star is equivalent to a massive blue supergiant, whose mass and density is of a sufficiently large enough size such that the resultant core implosion, following the pattern of Hypernova, gives birth to a neutron star of the Superverse. Most likely, the type of star system in the Superverse in which this Hypernova event occurred was very much like the Eta Carina system in our own Milky Way galaxy. Specifically, it was a binary system containing two massive blue supergiants whose death would give birth to a pair of neutron stars, thus becoming a binary system of two neutron stars. Like our universe as we know it, the Superverse has its own fabric of space-time that can be warped and bent in a manner described by Einstein's field equations of general relativity. The only real difference between the Superverse and our universe is one of scale. It is this space-time fabric of the Superverse that will ultimately become entrapped in the creation of our universe. And like the fabric of our universe, gravitational waves can form and roll across the fabric of the superverse, a supergravitational wave, for want of a better term. The two neutron stars of the superverse, like our universe, can be described as being almost the most perfectly homogeneous form of matter with respect to the superverse. A neutron star is effectively entirely composed of neutrons, where each neutron within that star has exactly the same mass energy density as all the other neutrons within the star. Coupled to this is the observation that the neutrons within the neutron star are all equally packed tightly together, such that it has a uniform density. Hence, the same mass energy density exists in all places within its volume. Hence, we have two objects, neutron stars, whose mass energy density is homogeneous. Now, in a similar manner with respect to the superverse, the superneutron star, being composed of superneutrons, has the same properties in that its mass energy density is also homogeneous. Also, the total mass of each superneutron star is greater than the total mass inside our observable universe, remembering that a pair of child universes are born from the subsequent birth of a rotational black hole within the superverse. Drawn towards each other, following the curvature of the superverse's fabric of spacetime, the two superneutron stars spiral in towards one another. As they spiral in closer to one another, they distort the superverse's spacetime fabric in such a way that it gives rise to supergravitational waves that ripple out across the fabric. The pattern formed is one of two spirals, each one rotating outwards from the central locus point of the superneutron stars. Finally, they collide, and the kilonova event begins. In this collision, a number of key things happen. Firstly, the merger of two superneutron stars creates such a large concentration of mass energy density that the two stars effectively undergo total supergravitational collapse. The angular momentum of the spiraling superneutron stars' collision in turn imparts rotation to the newly born black hole of the superverse. The second key component comes in describing the R process of nucleosynthesis that occurs as a result of a kilonova event. Here, the rapid neutron capture process occurs where subsequently increasingly heavier elements like gold are alchemically forged. This alchemical creation of the heavier elements arises from the fragmentation of the two neutron stars as they collide together, the true philosopher's stone. However, in the case of the superneutron star, it is the heavy elements of the superverse that are forged in the Big Bang Kilonova event. These heavy elements of the superverse in turn find themselves inside the newly born rotating black hole or are sucked into it. Traveling through the embedded wormhole and out via the rotational white hole, these heavy elements of the superverse come to exist inside the entrapped space-time that is either our universe or our parallel twin universe. But to us, these massive super elements become the supermassive black holes that in turn are the seeds for galaxy formation. The third key component that accompanies a kilonova event is the production of a pair of gamma ray bursts. Now, what exact relationship there exists between the entrapped child universe and its associated gamma ray burst is a mystery. If a relationship apart from a common source, the kilonova event, exists. Originally, I was imagining the universe to be entangled or actually the gamma ray burst itself. It was the thought of two jets moving in polar opposite directions with respect to each other that I saw as a solution to the matter-antimatter asymmetry problem that put me on the path to developing this hypothesis to begin with. But it was in seeing how the birth of a rotating black hole via the Kerr metric could give rise to a pair of new child verses that allowed me to complete my vision. What is more fundamentally the critical ingredient is the massive electromagnetic field that is generated in the kilonova event, which subsequently shapes both the newly born pair of child universes and the pair of gamma-ray bursts. In seeing the structure that is shaped by the electromagnetic field, I have shown via my first computational model how a concentric ringed universe is shaped. Specifically, if we imagine my computational model as being analogous to the scattering of the supermassive black holes as they are ejected from the kilonova's white hole. The super neutron stars collide, and the rotational black hole of the superverse is then born. Falling inside the rotational black hole, we travel down and through the embedded wormhole and into the newly born rotational white hole. As the rotational white hole begins its outflow of the scaled fabric and fields of the superverse, so are two new universes born into existence, one being our universe of matter, and the other whose direction of expansion is in the polar opposite direction to our own. As argued in my CPT symmetry in the Superverse film, I consider the helical spiral escape paths of two opposing particles, ensuring why we live in a charge, parity, and time symmetric universe. These helical spiral escape paths are formed from the solenoid-shaped super electromagnetic field. Now, in previous work, I talk about how long gamma-ray bursts are shaped in the heart of a hypernova. The same shaping process is in effect in the heart of a kilonova, in that a solenoid magnetic field arising from the merger of two neutron stars channels the explosive energy into a pair of short gamma-ray bursts. Another important point to remember in thinking about the birth of a rotating black hole in the superverse is my argument of scaled recursion. That is, the quantum and gravitational fields that make up the superverse are effectively crushed and scaled down in effectively what could be called the big crunch of the superverse. Thus, when these fields are ejected into either one of the twin child universes, the same pattern in the laws of physics are inherited by them, meaning the only real difference between the laws of physics as we know them and that of the superverse is one purely of scale. So no fine-tuning of constants, but rather our universe plus our parallel universe of antimatter inherit the fields and hence the same laws of physics as seen in our parent superverse. Like two twisting bubbles of entrapped spacetime, our twin universe begins to expand. It is expanding into the surrounding volume of the superverse, whose curvature is mostly flat. Thus we see both a measurement of a flat universe, which is closed at the Planck scale, as evident from the cosmic microwave background radiation. However, although the curvature was mostly flat at the time of the cosmic microwave background radiation, there is one form of curvature that dominates the region, namely the two spiral-shaped supergravitational waves emanating from the Big Bang Kilonova event itself. These massive supergravitational waves in turn shape the large-scale curvature of the entrapped space-time of our own universe. This imprint upon the microwave sky, as we have so carefully seen, are responsible for large-scale anisotropies. Lastly, keep in mind that there is only a finite amount of matter being ejected into our newly born universe from the rotating white hole. So at some point the outflow of matter from the white hole will stop, and when this does, a void will open up between the white hole and the rest of the observable universe. Thus, as this void opens up, so too does the void region called the Eridanus supervoid open up and form. In turn, the vast bulk of our Jetiverse begins its journey across the expanse of the Superverse in the direction of the Great Attractor. And that, in a nutshell, is the Big Bang Kilonova Hypothesis. Until next time.